Vectors come up a lot in physics, and one of the key ideas with vectors is vector components. So let's take a look at how vector components are defined and how we can determine what they are. First, let's take a look at this problem. This problem says, what are the x and y components of the vector below? So this blue line right here is clearly a vector. It's got a magnitude, a size, and it has a direction. And what we're looking for is what are the components of this vector, specifically the x and y components of this vector. Vector components tell you how much of the vector is in a given direction. So the x component tells you how much of the vector is in the x direction, and the y component tells you how much of the vector is in the y direction. So let's take a look at this problem. We're looking for the x and y components. So right at the tail of this vector, it's probably not a bad idea to just kind of draw a little mini version of a y and x axis. Just to remind you that we're looking for how much of the vector is this way in the y direction, how much of the vector is this way in the x direction. And the x direction, the x component, is how much of the vector is in the x direction. So what I'm going to do to find this is I'm going to start at the tip of this vector and just drop straight down, meaning parallel to the y-axis, drop straight down until I reach the line of the x-axis. So I can imagine that the x-axis is this way, and I'm going to go until I just reach it. And then that's where I'm going to draw the tip of my x component. And I'll just fill in the rest. So dash, 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 dash for my x component. So I'm going to label this red arrow down here x component. For the y component, it's the same kind of situation, but I'm going to look vertically. So I'm going to want to know how much of the vector is in the y direction. I'm basically going to say, if I go parallel to this x-axis, where do I hit the y-axis? And so this is the line of the y-axis. And if I drop back parallel to the x-axis, you can see that I'd end up about there. So that's where I'm going to draw the tip of my y component. And I'll just go ahead and label this vertical arrow as y component. That's one way to draw the x component and the y component. For me personally, I prefer having the y component over here. So I'm just going to move this. I'm going to redraw the y component so I can really clearly see that this is like a right triangle. So I'm going to go ahead and erase what I've drawn here for y component and draw the exact same size arrow, the exact same length, but right here. And I'll label this as y component. This makes it easier when you do mathematical analysis because you can see, oh, this is a right angle. The x and y components are perpendicular to each other. Now for this problem, all it wants to know is what are the components. We've drawn them in, x component and y component. And assuming this is a length diagram and this is your vector, all you'd have to do is measure the length of your x component and then measure the length of your y component. That'll get you the magnitude of each. Now later on you're going to be doing mathematical analysis. You look at sines and cosines and how to find these mathematically. But for now, it's okay to just look at this and say, I've drawn in the x component, I've drawn in the y component, here's the magnitude of the x component, and here's the magnitude of the y component.